Hello, this is Clayton with Aeromotive Research and Development Group. Today we're going to be talking about advanced break-in procedures regarding engine and drivetrain preparation, performance, durability, and metal surface improvement. Why is break-in so important? Isn't that a necessary evil? No. Break-in procedures increase metal surface technology by using heat and operation cycles to activate the micron metal sponge environment, in other words, the pores within the components and metal areas. The break-in process performs simultaneous combinations of 1. Matching components by leveling the peaks and valleys of the surface area, and 2. Releasing contaminants held within the metal's subsurface level, including the holding case. You see, the break-in procedure happens through heat friction and cool-down cycles when the metal expands and contracts like a micron metal sponge that opens and closes the pores to release and receive or soak in. Particles and contaminants are released into the fluid and flushed away upon hot draining. If you use the wrong fluid and the wrong procedures, all the money you put into the motor will be gone. Now, for maximum benefit, if possible, you really need to preheat the oil to, let's say, 150 degrees. If not possible, then you got to use caution. All right. The goal is to reproduce long-term power-up dyno processions by top engine builders, or you could be an engine builder. Now, we also understand what you have to do is have the ignition off, spark off, turn the engine over for 30 seconds until the oil pressure starts to move. Or in other words, you hear the oil within the engine. And then you start the engine, let it run at a smooth idle, get everything going good, sounding good. Then after initial idle, full oil pressure is achieved. Set the idle at about 1500 RPMs. Let it run until full operation temperature of the motor for the water and the oil is achieved. Now, the other reason you need 1500 RPMs is for a clean fuel burn and for that to happen. You see, the goal is not to let oil pressure or the fuel to load up, becoming rich within the fuel at idle. And also remember, the engine is sitting and airflow needs to go into the radiator or prepare to use a fan if you're just breaking the motor in. Basically, it's like this. Start the motor, let it run, let it come up, and just let it set and do its job before you start getting into high RPM situations. Now, if you're going to have a hot run that's with your vehicle, you can try to do that if you want to be able to break the motor in a little more on your car, but just make sure that the sessions are like it. It's light, medium, and full throttle sessions. Okay? You see, you need to perform heat and cooling cycles at least 3 times, increasing the intensity. When the process is finished, in other words, you've got full compression inside of the piston and the ring area, and the breaking in of the cam and the lobes, etc. Immediately drain the fluid. Don't keep running it. And then replace the filter and replace the oil with a high-performance racing oil. Now, these procedures that are done on the engine are also required for the rear end or the manual transmission as well. All right, if you've got brand new gears and everything, they have to be set and matched. Well, Sinmax has a brake-in gear lube specifically designed for this procedure. All right, then as soon as everything's mated in and you've gone through an acceptable torquing procedure, drain the fluid and replace with a qualified synthetic racing fluid. Here's a question. For surface preparation, is this really required for metal surface technology to be absorbed in? All right. Well, you see, when a component is scheduled for what we call an aerospace coating, in other words, cobalt, diamond-like additives, moly, whatever, usually it's prepared through a variety of what we call sonic cleansing or micro-level machining and heat cycles process before it's applied. Okay, so there's a tremendous amount of sub-cleansing that has to be done. And what we're trying to share is this. when you got a break-in or run-in process, your top teams, they've already spent the money to do this. And depending upon your engine builder, he just might only spend an hour doing it. So you might have to do a continued cleansing procedure within the engine. And this is where the break-in oil will come in. Now that's not for racing. That could be like in a test and tune situation. All right? Because you might not have all the money that those high-end teams do, but you can try to reproduce it the best that you can by having an additional cleansing procedure within the motor. Now, we shared about this. The whole key is you have to be able to have cycles to run in. As we show here, our elements that we're trying to do is to get the rings to match properly within the crosshatches that's in the cylinder walls. And then also we want to get the lifters and all the components within the cam lobes, the cam bearings, etc. Everything cleansed and mated together. All right? So this is where the break-in fluids are very, very important. If you cheat on these break-in fluids, there could be irreversible damage that takes place within the combustion chamber and other elements of the engine. So please do not cheat on this. Get a qualified break-in motor oil. Now, again, as mentioned before, we have to be able to, within the cam and the cam load, within the piston and the other components within the engine, we have to get all these components to mate together properly, to smooth out the peaks and valleys, to get the subsurface metal that's within the block or within other components of the gaskets, of the sealants, of the silicones and other materials. They need to be flushed away at the draining of the brake oil when it's hot. And then don't be a cheap guy, swap out the filter. Now, you might say, well, I thought the engine was already broken and ready to go. Well, dyno time is expensive, and they might ask you to complete it by extending the procedure and doing it yourself. All right? Because it is true that steel and aluminum case surfaces can have particles that'll break off into the oil. All right? And that only happens at temperature. So again, we need to get these contaminants flushed and out of the system. Here's a question. If the component surface is micro-polished, is there any further concerns? Well, there is. All right, because if the gear or metal surface that you're working with is micro-polished, how is oil supposed to stay and lubricate it? All right? You always need a slight micron area for the oil to stick and hold, like crosshatch swirls on cylinder walls. Unfortunately, as we showed before, when you've got like the diamond-like additives that's in the oil, it performs a situation of refreshing the DLA, the diamond-like additives, into the surface of the oil, and it's an environment what we call plasticity. What's that mean? When the metal expands and contracts, the additive expands and contracts with it. Sometimes when you have additives and they're not correct and they're not working well, they will break off and go into the oil, and it's a mess, and you don't want that. All right? If you look in the diamond-like additive presentation, you'll see where the surface, even at like 500 times magnification, is so much better with diamond-like additives. But the key here is this: just because it's smooth doesn't mean it's not going to work that well. It might have the opposite effect. For instance, if you had a drop of oil on a mirror and you move that mirror, the oil would go right off, right? Shoo! It'd go off. But if you had like fine sandpaper, a little bit of oil went on there, the oil would stay on there and it would move so that the oil could be able to lubricate. All right? So that's very, very important. Okay? So just consider that the next time you want to go into micro-polishing everything. Where's the oil to stick for it to lubricate? Because it's like this. If you didn't have those honing crosshatch swirls within the cylinder walls, well, the piston would burn up because the oil wouldn't stay there, now would it? Furthermore, you need the oil to stay in the crosshatches to help provide kind of a sealing property for the rings in the wall as well. So that's why it's so important to have a qualified racing aerospace type oil in your engine. Now, if you were to select a break-in motor oil, what you should do? Well, we've got a product here at SynMax. It's a break-in petroleum motor oil. What it is, 100% mineral oil. In other words, it's like a Group 2 oil. All right, non-detergent, high zinc, because you can't find these oils anymore. They have to be specially made. All right. Well, I used to use diesel truck oil. Well, diesel truck oil, if you can find it from like 10 years ago, is fine. But the diesel truck oils today do not have enough zinc. They've got too much detergency, and it's really not what you want for the break-in process. All right. So you need to get the exact product made for the exact application for qualified break-in. Now, the translation for the application is this. During the break-in and power-up procedures, the high levels of anti-wear additives are needed for the valve train. There's many times where somebody just wanted to buy cheap oil for a break-in, and then they destroyed $2,000 worth of valve train. Seriously. Or they didn't get the right break-in oil, and then they just wore out the cylinder walls, and then they cry in their beer. Well, I don't want that to happen to you. So get a qualified break-in oil either from SynMax or there's other companies. Make sure that it's a low detergent, high zinc oil designed for what it has to do everything that you want. And please pre-warm the oil before you do it. So in conclusion, thank you for being with us during our break-in procedures for metal surface improvement. This is the end of our presentation.